Wednesday edition of Manufacturing Hub. We've got Dave Neville on here who we'll introduce in just a moment. We've got a bunch of awesome topics to talk about, including robots or robotics as a service, which I think is the first topic that Dave and I actually connected on and had a conversation with at some point late last year. And I think it's interesting. I think you guys will think it's interesting. And then just going and talking about everything on the robotics side, we're going to get into robotics as a service. We'll get into arms. We'll deal more into AVGs and AMRs as we started talking about briefly with Courtney. I will say, if you guys are watching the normal show today, because you were expecting a normal show today, yesterday we had part one of this week's of robotics theme, because last week was absolutely insane with all the conferences. So we had Courtney Fernandez episode 134, where you guys can go check that out. And that was just an awesome conversation. And I feel like it set us up for this. And I feel like this will set you guys up for going to listen to the conversation that we had yesterday with Courtney. So saying that, we do want to thank the folks at Solus PLC for sponsoring this. And if you guys don't know, that's Vlad's company. And I like to point that out because it embarrasses him like medium to moderate every time. And so longtime listeners know, I feel like for the first 50 episodes, I did something to slightly embarrass Vlad every single time. So go check out the Solus PLC robotics course that they have put together. I will say, if you guys want to know more about that, Pavel Krupa episode 133 is the instructor, and so he went to go build that. So if you guys want to go learn more about robotics, go ahead and check that. It is a shameless plug for Vlad, because we know all long time listeners know Vlad will not plug his own stuff, and so that is why there is a Dave here. And we will probably have absolutely, Vlad. We'll probably go ahead and have a number of those jokes. Last but not least, if you guys are new here, welcome. If you've been here before, welcome back. If you are new here, you might not necessarily know how this goes. We like to have fun, open conversations. Every month we pick a topic. This month we're obviously talking about robotics. We've got 4 guests that come on. Wednesdays at generally 4 o'clock, unless it's the one time a month that we decide we can't make Wednesdays at 4 o'clock work, in which case we do it at some other point in time. But you guys are here at the right time, Wednesdays at 4 o'clock. We have a very active chat almost all the time. If you guys have questions, please feel free to go ahead and drop them in the chat. If there are responses and other things, please feel free to go ahead and do that in the chat as well. Almost exclusively, we will run into issues where we've got too many questions, or we've got issues with questions coming in, or the questions are too technical to go answer on this, in which case we will do our very best to come back and answer those questions at a later point in time. But without further ado, everyone officially welcome to Manufacturing Hub. This is episode 135. My name is Dave. This guy down here is Vlad. We have a very special guest, Dave Neville, coming on. Dave, thank you for being here. Welcome to the show.
Thanks for having me, Dave. Same, Vlad. Appreciate it.
Definitely. Thank you so much for taking the time today to speak with us. Before we dive into maybe the discussion on robotics, could you give us a bit of a background of yourself? How did you get started in industrial automation? What was your career like up to this point? And ultimately, what are you up to today?
Got it. So I started probably one of the first robotics clubs in 1985. Built an AMR with an arm on it. 40 years later, we're putting arms on an AMR. So we've advanced a lot in 40 years from what I can tell. Got out of that a little bit. I spent 10 years with UPS, 7 years with Sears, and I was a mobile DJ for that 10 years, all 3 at once. Got out of that and I went into headhunting. So I basically dealt with embedded hardware, software engineers and mathematicians. So think a lot of medical device, a lot of military type products, and a lot of industrial projects. Decided
Why
I
headhunting?
Headhunting.
Sorry to interrupt. Why? Like, was there like a motive behind trying to understand that side, or interest, or how did that come to be?
You know, I kind of fell into it a little bit by accident. It turned out I knew a lot more about engineering than I thought. Knew a lot more about the customer's processes and equipment. And I really enjoyed talking to engineers and advocating for them to get on the career path that they deserved. Good and bad, sometimes engineers aren't the best for advocating for themselves. And I found that being an advocate for engineers, particularly to help them stay on a career path that interests them versus just a job. So I did that for about 15 years. While I was doing that, I decided I wanted to learn manufacturing. So I opened up a company called Kuhn & Inc., and we manufactured high-end handguns, AK-47s and FNFAL, and a bunch of medical parts. Our slogan was, if We can't make something to cure you. Yeah, and the marketing department never liked that slogan. So decided to get out of that industry, and I was trying to decide what I wanted to do next. And robots have always been a passion, particularly AI and vision have always been a personal passion. So I went out and I ruined another hobby and I started a robot company. And basically, we joke we're a 35-year-old startup. I had been working with automated control systems with Brad Tooch for about 15 years. Decided it was time maybe for him to shut his company down and reform it, bolt robots onto this factory automation equation. And we then formed about 4 years ago, Infinity Robotics. I've been very grateful that we have pulled together a phenomenal team with a lot of talent. As a result, we basically don't specialize in an area of robotics. We're a very generalist. There are some specialties here and there we'll recommend a competitor to because we know they have a cheaper, good solution, and we always want to treat our customers right. So that's what kind of led me into robotics was what's cooler than making guns? Nothing. But
making guns with robots.
And that's what we do now, which is interesting you bring that up. So we're able to advise a lot of companies because we're familiar with what the pain they're feeling in their process and help them automate it as a result. And the gun industry was ripe for automation.
Curious, Dave, like on that side, was it did you buy a facility or was it a green field that you like redid the whole process? What was that like?
From the manufacturing side, Vlad?
Yes, yeah.
Yeah, so we had an old 10,000 square foot bay that we kind of refurbished into this, and then we moved into a green field and built the factory out probably in our third year.
Wow.
So we went through both, kind of using we had bought an existing machine shop. Dan Coonan owned a machine shop that he had been running, and we repurposed that to start remanufacturing a pistol that he had designed in the late 70s. I used to manufacture, for those who know what guns are, a 1911 357 Magnum automatic. It was by far the most exciting gun ever manufactured to shoot. There are bigger guns, there are some cooler guns, but not as powerful and not as much fun. Fun is the key word in shooting something that big.
Oh, that's really interesting. And I think that would be an episode in itself because I think, starting up something like that and obviously bringing in or building machinery from scratch to make that process happen was probably a huge challenge in more ways than one. But Dave, I guess like to bring us to today, so Infinity Robotics, just to understand it a little bit better. So you provide robotics focused services. Do you build cells? Do you also integrate controls? Like where's maybe the limit or the scope of what you currently do?
So we're known as a robot integrator. So what I do is I buy Kawasaki, Fanuc, ABB, pick the brand, Flexiv, Universal Robotics. We pick the right robot for the system. We integrate the PLC, so we do all the controls. And when I got into it, I knew the secret sauce was going to be vision. Vision and AI is what was going to change it. As I laughed when I got into it 5 years ago, I was shocked that we weren't doing anything much different than 1985. And since I said that, I have eaten my words about every month since then, because there's been one massive breakthrough after another in advancing vision and AI into robotics.
I guess, can you give us a few examples? So I'm familiar with, the old DVT style cameras, then transition to Cognex, but none of the maybe like AI ML applications. Like what are you seeing that's been like groundbreaking?
So we're taking things like as simple as a couple Intel IP cameras and making a 3D scanner. That's the basis of an Augmentus system from Singapore that we use, to the point of putting an LMI Gocator with a laser scanner. So we're using RGB, we're using black and white, we do some IR vision, infrared for those of you who don't know. I'm shocked we're not doing more with UV in vision. I don't know why we would look at anything other than in UV. So we're kind of bringing some of that into our lab and seeing if that doesn't play out a little bit better.
Gotcha. Yeah, it's really interesting, like, again, because I think, like, I've seen some of those demos, like, on trade show floors, but I've not maybe seen some customer applications that I obviously had some ideas of what, a 3D system could offer, but I've not seen maybe like specific applications. That's why I think it's very interesting for sure.
So we like a specific application, we were making refrigerator drawer assemblies, and we had to use vision to find the hole, where to put the screws. We had to use vision to find the 6 different parts we were putting together. Some of that was some simple, just photo eye type stuff. There was a couple Cognex cameras, a Keyence camera, and then the final process, we presented that assembly to a camera that measured certain components to make sure they were in the right spot. So the nice thing with the robots is we're incorporating more vision. We can really improve the QA process. We can actually create a record from beginning to end of how that part was handled. Now, in a refrigerator, not super important, but in some of their aircraft customers, and specifically our medical device customers, that record of how that component was made is huge should there be a problem 20 years from now. You can sit there and pull up those pictures and go, this is how it left our factory. Here are the steps we took to make sure we were doing it right and well. So we think we have a huge improvement on that QA, better quality parts. And quite honestly, the vision just allows us to do some really cool, crazy stuff with robots that you can direct fixture this stuff as much as you want, but as soon as you add vision, it's a lot faster and I think a little more streamlined.
Dave, what are your thoughts?
I think it's interesting. I think to Dave's comments and then to Courtney's comments yesterday, I think that we will only continue to add more cameras, more vision to make these robots even smarter than they are now, especially as we look at putting robots on AMRs, especially as we look at putting robots on carts. And I'm sure there's a more technical word than carts, but we see lots of
Our
robots.
technical term, David, is cart.
Perfect.
So
just saying. I'm now a robotics expert, Vlad. But no, like especially as we see more robots going on carts and those potentially having multiple geolocations, so that we can go ahead and move different things. I think it's very exciting. And as everyone who has heard me talk about it, I am certainly not a robots expert, but apparently I know all the lingo like carts, which is very exciting. But I continue to see more and more applications, especially as we see fewer and fewer humans who are willing to do the job. And honestly, maybe more and more common sense of maybe I shouldn't have the human doing that same repetitive task for 8 hours a day, 6 days a week for the next 30 years if I can find someone to do that. So I think that's very interesting. I want to slightly transition this conversation over into robotics as a service. And as I said, kind of as we were getting into the beginning, I had made a post of how I think, at least conceptually, robots as a service it's very conceptually very interesting. And there are lots of reasons why people would look at them. There are probably lots of reasons why people wouldn't look at them, especially larger companies who can go take that CapEx write-off. But I think as we look at transitioning into kind of the next era of robots, instead of saying, hey, this robotic cell is just going to, for round numbers, cost $100,000 or $1 million, you can go buy it for, I don't know, $20 per hour or $50 per hour, kind of all inclusive. So to me, conceptually, it's very interesting. Dave and I had a bit of a conversation surrounding this at the end of last year. Dave, I would love and we will go paint you as the expert, because you're certainly the expert in this conversation about robotics as a service. Can you perhaps give us a little bit more background and tell us kind of the conversations you're having around them, please?
Got it. So it's a conversation we bring up often with our customers, trying to help figure out how would they like to finance their cell, if you will. Robots as a service, probably one of the more BS things we've come up with so far. But let me back up a little bit. If you buy your robots on a regular lease, it's a CapEx, capital expense. The advantage of robots as a service is you can do it as an OpEx. So it doesn't hit your current tax laws keep it from being a liability on your books. So if you're owned by an investment firm, they like that robots as a service model because their balance sheet, their EBITDA looks a little better. The other advantage with robots as a service is if you're a plant manager running or plant engineer running a plant, you have the authority to go spend $150,000 a year on salaries. I'm just making up a random number. And you need to go spend 40,000 to do a particular task. Well, if I can rent that to you for 35, 38 grand for the year, you already have the line item to approve and bring that in. But I think, as people look at this, they really think they're renting that robot by the hour. And this really is more of a tax play than a hourly. You're contracting X number of hours every month, and you're paying that whether you use it or not. Most of the models at the end of your contract, you have a couple months to use up any unused hours. So you're not necessarily losing that money, but you do need to kind of plan, carefully and make it. And you are right. The neat thing about robots as a service is I can often put a cell in for 20 to 28 bucks an hour versus the $32 an hour you're currently burdened with that human. Our goal isn't to replace humans. We're trying to redirect humans in the factory, give them, safer, better jobs that use their brains. And robots as a service is a way to help, reutilize that labor force that you currently have. Now, I say that, it's a little bit of BS because we often do this robots as a service bid so the CFO can go, well, if I just buy it outright, I save $100,000 over 5 years. He now gets to put $100,000 in his bonus column and shows the board how much money he saved. So this is actually a tool we use the plant managers to give to the CFO to get the CFO over the burden of we don't have money. Now we're helping the CFO show how he's earning his bonus. So when you understand the politics of it helps. Now, there's a huge advantage to doing robots as a service as we take on all the responsibilities for maintaining that cell. So your annual maintenance, your occasional down times, if the robot goes down, we actually pay you by the hour that it was down. So companies do like that. Now, I'm talking more about traditional cobots and industrial arms. We're hoping to see about 10% of our customers take on robots as a service. We think it's great for about 10% of that market. It's bringing in about 40% of our customers, though, by offering it. So the fact that they have this as a choice gets them to the table a little bit faster, and we're helping them make a decision sooner. Now, there's a huge exception with this. We think AMRs are a perfect model for rental. They're high wear, they need constant maintenance. Depending on your environments, people might be crashing into them. Your situation changes. You have wheels that are hitting pavement that, like your car, they wear out after a while. So we do think the robots as a service on the AMR side is much stronger and a little better value for the customers in the end.
I wanted to ask, from the logistical standpoint of rolling this out, I'm assuming that you would also provide the service of engineering, let's call it the cell, and then deploying that cell, or is that like a separate column that is, an investment that they also need to make? What does that look like?
So typically, whether it's robots as a service or not, customer comes with us with a problem. We identify the types of equipment and processes we have to replicate or manufacture with the robot. We go out, we get the robot, we might be adding conveyor belts, we might be incorporating a CNC of some sort, and we're tying all that together into one system. Usually we're building that on our floor, testing it, and then we deliver that to your facility. But because we already built it and tested it on ours, it's going together faster and we're not debugging as much on your floor. Not interrupting your operation is the key thing there. And then from there, that robots as a service, that's what that rental was all the engineering to design it, to purchase the equipment and install it. That's all kind of rolled into that contract, if you will, of I want 330 hours a month, I want 450 hours a month, whatever that monthly usage you anticipate to need the cell. And then obviously, whether it's a 3, 4, or 5 year contract, you're doing 1 versus 3 shifts, your hourly rate drops quite a bit, those variables. So like I said, if we're selling $200,000 worth of equipment with $100,000 worth of engineering, that's going to be rolled all into your $28 an hour rental fee. Does that answer the question?
Yeah, definitely. I think that that makes sense. And I guess like as a follow-up, like once that contract expires, I'm assuming it's just an option to purchase the cell outright, or it would be, like you guys come in and decommission. And I think like that's also like a question, on that side for robots as a service, because ultimately I know decommissioning projects are fairly laborious, let's put it that way, and things are almost sold at scrap value at some point, but you can refurbish like robot arms, but not everything is salvageable. Like, what does that maybe process look like?
So part of for us to put this in a robots as a service is it has to be what we deem as a redeployable system,
Gotcha.
which is one of the biggest BS sales pitches anybody gives a robot customer ever. Robots are not redeployable in the way that we would like them to be. They can on occasion, but more often than not. Typically, the reason why robots as a service came in is we know that the second we bolt that robot to the floor, it's never leaving your facility. You're not going to decommission this. You have the option. So at the end of, say, your 3-year contract, your 3-year agreement, you have a couple options. You can buy that system out at a very significant discount, which makes it a little more affordable, or you just re-up your rental agreement at a much reduced hourly rate. We do it in a way to make sure that it's tempting enough that we're not ever picking up the robot and bringing it back to my shop.
Right.
So
I assumed so, but that's why I wanted to ask to like actually understand like what
you're
you
never
mean.
going to turn down the re-up contract because the savings on that is amazing. It's almost like just having something there for free. You're talking instead of maybe 28 an hour, it might be 14, might be $9 an hour, depending on how we depreciated that for you. Some of that will depend on how well you took care of it. If it's super beat up, we're going to jack up the price because we know we've got to do a ton of work on it because it wasn't, there was abuse, not just not maintained, but it was a really abused environment. Versus if people are keeping it clean and kind of doing their part, we feel the risk is less, so your hourly rate's going to drop precipitously as a result.
That's an interesting point, right? I haven't thought about it, but it's analogous to, like the meters you could put in your car to get your insurance payments down, because ultimately you will be having to do maintenance ongoing on your robot. So if you see that it's well taken care of, then obviously you can kind of reduce the premiums and vice versa, right? It's been,
Well, the
the
beauty of it is
environment.
we have a couple of years of history of how you abuse and or use your equipment. How often are we out there on a service call that maybe is kind of questionable as to whether or not needed to be made because people weren't being respectful? So if we've got 3 years of good history for you, we can drop that price down to literally you're just paying me to pay for your downtime and show up and do maintenance on an as needed basis. So those are some things to keep this isn't a rental car from Avis. We aren't beating the snot out of it and turning it in a week. You're probably going to live with this thing for the next 10 to 20 years. And we, to be honest, we haven't gotten to the point where we've had anybody renew yet because we're still new into this. We launched this last year and end of last year. And a lot of discussions around it. But again, I think where this is really going to play is as we've brought in some new AMR lines. I think the robots as a service is a huge benefit for that.
It definitely makes sense now that you kind of break it down and explain it. Dave, any thoughts on your side?
I like the concept, and I perhaps like it more than Dave or anyone else actually selling it does, and I like it because I think the inclusion of the service and the maintenance and all of that, and the fact that if the machine goes down and it's Dave's fault, Dave has to go pay whatever that downtime rate is. Now, I'm sure they're probably not paying $50,000 or $100,000 an hour, because that would way jack up the rate of a robot. You couldn't possibly spend $9 an hour for uptime and negative $50,000 an hour for downtime. That
Our contract is the same as we bill them. We pay,
okay.
So you pay your contract, we write you a check for a refund for any hours that are down. So if it's 28 bucks an hour, that's what we're charging. Now, as some of you are out there thinking, well, why would you ever go fix it? You could wait forever. No, we don't let those sit down for very long. It's very important that those, it's important to these companies, their production and the profitability of their company. And we're very respectful of that. Yes, it does cost us $180 to go fix them, but you're only paying us $28 for the downtime.
Absolutely, and kind of to that point, I feel like lots of longtime listeners have heard me talk about misalignments with many groups. I feel like there is an alignment of everyone wants to get the robotic arm up and running because it's costing literally everyone money. Different levels of money, but it's costing everyone money. And I like the concept of building that service in. When I was an integrator, I worked on different opportunities of how can we build this service in and how can we build it in a way that makes sense so that we can guarantee ourselves, X number of dollars or X amount of work over the course of the year. Because if you've got 50 or 100 clients like that, then you can go have one or two or three or however many folks who are just focused on going and servicing those. And it helps to grow the organization more organically. And to Dave's point, you're very rarely going to say, no, Dave, I hate you so much. I'm ripping your robot out and I'm putting the exact same robot in the same place. So I think for many ways that makes sense. And for longtime listeners, I work with a lot of especially kind of mid-sized organizations, and lots of those mid-sized organizations may not have necessarily the upfront capital or the ability to go to the bank to get a loan. And if you don't have the ability to go to the bank to get a loan, paying $28 an hour, or even if it's $50 an hour every month makes a lot more sense.
And we agree, Dave, for the smaller operators, that often makes a really good choice for them. And
absolutely,
what we love about the smaller operators, they care about their business. They also care about the cell we've rented them. So another thing we've done, whether it's a robots as a service or not, is we're including and layering a lot of third-party software to, for instance, last week we launched a robot that's programless. The robot programs itself now. We put in products like OLIS, where we get a 30-second feedback. If the robot crashes, we get 30 seconds of video. We get all the fault codes before they hit the reset button, then the reboot, then the reset, then the reboot, reset, reboot. Now call Dave and find out why my robot went down, and you've just erased all the information I need. Absolutely. Our whole thing when we sell a cell to a company is it's a 15-minute phone call to get you back up and running. Of course, the big drawback we found on this, because it's working really well, is the problem with the 15-minute phone call to get your cell up and running is it's not long enough for us to charge you for that call.
Oh.
And all our customers giggle and laugh at that. But it's important for us that they're not having downtime. The idea behind automation is that it's robust and that we've thought through what can go wrong and should be able to recover quickly. So it's very important you plan and program the systems right up front. And then we have tools like this so that if something is missed, we get to see the video of the guy bringing the I-beam through the cell, smacking into the robot, pulling it out quick and running away. Why did the robot crash? Now we know. We can actually see what it did. And a lot of times that's kind of an egregious example, but more often than not, how the robot's actually being operated, how the arm is actually moving tells us what was going wrong as well. Somehow the code got corrupted. Somebody went in and changed a parameter. Something happened. So by seeing that 30 seconds is just huge. We aren't wondering, we know.
Absolutely. I love that. I would like to slightly transition this into kind of that AMR conversation. I know that you said AMRs are, at least theoretically, much more set up for robots as a service. So we talked a bit about them yesterday. So again, if you guys caught Courtney's conversation, she talked a bit about them. I will say, she said that some of these things have like 200 or 300 kg payloads. And Vlad had lots of really good questions. And my first thought is I want to go get a video of me surfing on one of these things as it's moving. So everyone should go back and listen to that. But Dave, can you tell us a little bit more about AMRs? Tell us a little bit more. Yeah, can you give us a little bit more about what AMRs are, kind of the use cases you see, and then maybe if we can talk about how they potentially are better as a service because of the use and abuse they see.
Got it. So we do everything from 250 kg AMRs up to 500,000 pounds. I'm not sure what the kg conversion on that is.
A lot.
So we carry a lot of different brands. One of the ones we're super excited about right now is PEER, P-E-E-R. It's was designed or funded by Black & Decker for the design in India. And they're bringing them over to the U.S. to be assembled in the U.S. And it's basically a $32,000, $35,000 AMR compared to our competitors at 45 to 70. So the big problem with AMRs have been the ROI It's hard to spend 50,000 on something that's literally just moving material back and forth. When you realize how much time is wasted by your humans doing it, it's a faster ROI. But what we've been told by the biggest companies in the world is 25 grand is the magic number. 45 really isn't working. We've got something that's about within 10 grand of what they think is a great ROI. And let's be honest, all customers are cheap, so they're going to be a little off. Actually, this robot, if you're buying 100 or more at a time, we can get it for 25 grand a piece, about just north of that. So that's a huge game changer. That's another great one for robots as a service, because that thing could run you as little as $9 and $10 an hour to have in your operation. So you could have 3 of them in there for about $30 an hour, and you're replacing at least 1 to 1.5 people moving material back and forth in your factory or lab. Our whole thing is trying to figure out what our customer use cases are. Most of it is material moving. We have been and will be at ATX on October 10th and 11th in Minneapolis. We will have an AMR with an arm mounted on it. The key thing is our customers want to move arms from station to station to do subassembly and QA tasks. And these AMRs make it affordable. I can literally, probably by this time next year, I'll have an AMR on it with an arm on that'll be just a little over 100 grand, which is just mind-boggling at that point. We do a lot of very narrow aisle VNAs, very narrow aisle, counterbalance forklifts, so moving products around the warehouse, pallets, palletizing, putting it up on the pallet racks automatically has been a great ROI for our customers. Now those get into the $200,000 to $400,000 range, depending on payload, complexity, and height. Again, numbers affect. When you're buying 2 or 4 at a time, I get a much better price than if I'm building one at, my suppliers are building one at a time. We're brand agnostic. Our brand is beyond AMR, because we're taking AMRs beyond just trawling something around. And really what Infinity Robotics is trying to become is if you do remember who Sears Roebuck and Company was, they had a line of appliances called Kenmore. They never made appliances. They went to Whirlpool, Maypag, Amana, and they self-branded it. And that's what we're trying to be for our customers, because there's no one manufacturer that meets everybody's needs. But we would like to be a single source that they can go to, get the right products, the right support, 24/7 nationwide coverage, and be successful with their AMR integration and get a decent ROI for it, at least have that defined up front. And that ROI is very easy to define when I'm talking robots as a service. The math is easy. I'm going to 1,800 hours a year. I'm probably going to use this, times it by 10, 20, 30, 40 bucks, whatever the system looks like. And they get their operating costs right away. And when that's 10 to 20% lower than their current operating cost, that robots as a service model makes a ton of sense. There again, we see facilities change a little bit more option, where they might want us to come in and fine tune some of the movements or processes we're doing with the AMRs, so that robots as a service allows them to do that. More than anything, these are moving parts with motors that are not in a cage or in a predefined cobot package. They're exposed to dirt and dust and the environment where a normal robotic cell isn't going to be. So therefore, we do anticipate there's going to be a much higher maintenance routine with them. We aren't coming out once a year to change the oil on an arm and some batteries. We might be out there twice a year replacing tires, depending on how many miles you're putting on these.
Gotcha.
Of course, that's going to depend too on wear and environment. If you have an epoxied floor, they're going to wear better. If you have an open core concrete floor, you're going to wear out those casters and those wheels a lot faster. But keep in mind that open floor, you have better stopping and safety controls. So there's pros and cons to all of it. And those are the things we try and help our customers navigate.
Good follow-up on that, Dave. If I can take a step back, for someone who doesn't necessarily know AMRs that well, and I've certainly worked in facilities that have deployed them, but I've not programmed one myself. I wanted to maybe ask you, what are some of the not necessarily bottlenecks. I think that's not the right word, but what are the critical parameters when it comes to AMRs, right? So there's obviously one which is like the payload that you need to be able to like bring back and forth. Like there's probably programmability, right? Like how you set up those different like points where they go, and maybe like what else could you be looking at as someone who's trying to buy an AMR, and like what would be the critical parameters of one?
So payloads, as you brought up the first one, usually 250 kgs on the smaller, lightweight end. You're going to see it's not unusual to get into a 500 kg, so we can handle up to 1,000 pounds. We actually have where we can take 25, 30,000 pounds on a custom AGV through some of our suppliers. So that payload is huge. The environment is important. How many people, forklifts and other things are they going to interact with? There, some brands and some protocols deal better in a dense environment versus everybody does better when there's not a lot of interaction. How often are they going to drop a pallet in its path? So kind of depending on that environment, we're trying to size it for that. We're looking at time. So a lot of times I'll go and I'll do a time study. How much time is this person spending walking from one end of the factory to the other and back? And that's how we help them build that ROI and identify that. So distance makes a big difference. The longer the distance, the faster the ROI. Complexity. If I'm doing, say, wave picking in a logistics warehouse, we're going down 10 aisles and that guy can now fill that robot up with the BOM, the bill of materials, the stuff he's supposed to pick. He can hit, shipping station 1 through 1,000, and that robot's going to go to that exact shipping station and get that packaged and shipped out. Now that person gets to sit there, and then when he sends that robot away, it'll call another robot to him so he can continue loading. So, we're looking at how they're using it. Now, more often than not, we're looking at moving material through a factory instead of on a chain being dragged through the factory. We're now able to take that product from station to station to be built kind of like a Ford factory.
What about, I guess two other items that came up, battery life, right? So I'm assuming that robots need to come back and recharge. I don't know if it takes 10 minutes. I don't know if it takes 10 hours. But also,
yes,
I guess
you got that perfect. Somewhere between more than 10 minutes, usually not 10 hours. 4 to 6 hours probably is the normal, depending on the AMR. I mean, I have some that take 12 hours to charge. Now, it takes 2 days to discharge them. But typically about 4 to 6 hours recharge. And the robots are designed, almost everything we deal with automatically goes and finds that charger and recharges. Depending on how your settings are, if you're running a fleet manager that will sell software that runs a fleet of them, it'll pick the time that's a good time for that one to go down and be charged. Life on the battery of them usually is 8 to 12 hours. Again, it depends on how often it's being run, the payload it's running, the distance it goes. So the range can be 8 to 12 hours. Some of the smaller batteries are 6 to 8 hours, depending on what that usage looks like.
Interesting.
So
Go ahead.
If you're normally running out at 6 hours, we're going to tell you, at 5.5 hours, go recharge that robot. Normally, you don't want to take them down to 0 if you can avoid it. You're a lot less likely to have a robot stranded. And then the other thing, too, is keep in mind, it isn't necessarily stranded. You could always push it, but the batteries are easy to pull out, pop another battery in, and send it back to the station. And that's normally the schema we recommend with the customers. Have an extra battery for just in case somehow we didn't estimate the battery life right, you can get it back to home base.
Yeah, that definitely makes sense. You mentioned also fleet manager, so I'm assuming, and again, I've seen them in videos mostly, but you can get fairly fancy with like allocating different robots to different areas, and as you said, like one can go charge while the other ones take over. Like how does that maybe like set up or rollout look like? Is it you audit that and then you provide that as a service, or is that the factory that can reconfigure those things fairly easily? What does it look like?
So typically, if we're dealing like with 1 to 3 units, you don't need a fleet manager. You're going to set up individual instructions for that robot. But once I'm doing 10 to 30 on up, having a fleet manager that knows where the assets are in the building, it's looking at the health, and it's guiding what robot goes to what task. Again, robot 1 normally goes to station 2. The fleet manager decided the battery's low, it's sending robot 1 in, and now it's substituting robot 22 to go fill in for that. So if you think of fleet management as just you have a fleet of robots and it's helping you, it's self-managing itself based on parameters you set up. It just allows less interaction with your people with the robot as a result. I don't know if I explained that well or not, but
yeah.
I've never seen those, I guess, like tools or softwares. That's why, you know, like I obviously understand like what you're explaining, but I can't picture how difficult it would be for someone with, you know, maybe like robot arm experience to dive into that, because it seems like completely different. But
it's dirt simple. In fact, it's getting to the point they're letting me actually touch the real robots now because they have software that I can't break them now. But really, mobile robots, it's as simple as I'm in point A, push the button, push it to point B, push the button. It now knows the path, and you can set up hundreds of points. Now you could do that manually, or the nice thing with a fleet management is maybe you could redirect that for different robots, and you could actually use a pen or a cursor to draw the path that the robot should go. The fleet manager really is just kind of, it's a dashboard on your computer that if you can run an iPad, you're probably going to be able to run your fleet management. If you understand a few of the parameters of how you could tweak the robot, you'll get a little more efficiency, but you don't have to be a robot programmer to run mobile robots. In fact, as of last week, you don't even have to be a robot programmer to program the other robots, because we're putting stuff like MechMind and Augmentus on these robots, which they're very intensive vision systems that they get mad when I call it AI, but I've been putting AI algorithm developers in the market for 20 years. Guys, this is as close to AI as you're going to, let's be honest, as we want to get. I don't think we want the robots to figure out way too much.
I would agree with that.
So
absolutely. I would agree with that, Dave. I want to go dig into some more applications, but first we've got some folks to thank. So we want to thank the group over at Solus PLC for sponsoring this robotics theme. If you're an engineer or technician looking to break into industrial automation or upskill, Solus PLC is your go-to resource. They've got these super in-depth tutorials and online courses that cover all the nitty-gritty, from PLC basics to HMI and even robotics. And the best part, you're learning from people who actually do this stuff for a living. No textbook nonsense, just real-world skills that you can use. Thousands of students from companies like General Mills, Amazon, and Tesla are already getting ahead with Solus PLC. So whether you're a pro or just getting your feet wet, there's something for you. So what are you waiting for? Head on over to solusplc.com and get learning. Again, we want to thank Vlad, who is again slightly blushed from this embarrassment and the group over at Solus PLC for sponsoring this robotics theme. Go check out the new robotics course. I am sure it will teach you everything that will make you more of a robotics programmer than Dave and I. Vlad might already be above our level at this point. I'm sure he could certainly go hack it together better than at least one of us named Dave at this point. But go ahead and check them out. Go ahead and check them out. So, Dave, I want to go back to some of the AMRs, and you said
real quick,
go ahead.
Can I comment on Solus PLC? What we see repeatedly is robot programmers coming out of school that do not know how to spell PLC. Solus PLC gets those people talking to the controls engineer in a much more intelligent fashion, and you're going to save a ton of money by sending your people through Solus PLC so that they're on the same page as your controls engineer and you're not duplicating efforts in your design efforts. Vlad, very glad you have this product on the market. Sorry to interrupt, Dave.
Thank you.
That's okay. I am completely waiting for it. Typically, if we have someone from the sponsor go talk about the thing, we do, but we all know that Vlad is not going to go hawk Solus PLC, but everyone named Dave on this show is happy to go hawk Solus PLC. But no, Vlad makes a great product, and we are happy to go ahead and embarrass him when we talk about how great of a product he makes, which is what friends are for. Dave, so you had talked about some interesting statistics, right? You guys have ARMs from 250 kilos up to like 500,000 pounds or something like that. Can you help I mean me, because I ask very selfish questions. Can you help me understand what are some applications that we're going to use these smaller these smaller robots for versus what are we going to move with 500,000 pounds? Can you help us or help me with some of those applications, please?
Got it. Let's start with 500,000 pounds. Locomotives and rockets. That's a lot of it. Aircraft. It's big stuff. The vast majority of our customers are moving 5,000 pounds or less. Most of their racking can only hold 2,500 pounds.
Okay.
So when we sell a VNA or counterbalance, 3,000 pounds is really all we're looking for, because most facilities can't handle stuff. Anything heavier staying on the floor. We obviously can move that for them as need be. 250 is kind of the magic number. That's 550 pounds. That's basically 10 times what most of us should ever pick up on our own. So if you think 10 55-pound boxes, that's kind of one of the magic numbers in industry in general. So when we're looking at, say, 250 kg, which is about 550 pounds roughly, we're talking about smaller payloads. It might be an engine. It might be a transmission. It might be a robot arm on a cart, like a row EQ type cart that we can drop off at a station. And that really meets probably the vast majority of a lot of manufacturers. The next step up's a 500 kg robot. Typically that's going to handle up to 1,000 pounds, which if you're a shop doing a large weldment on a chassis, we could mount that chassis on that AMR and move it down the line for you. Think of an oversimplified car manufacturing line in that regard. Think more for like a skidster or an ATV type frame. From there, it really kind of depends. When I start getting into heavier than, say, 2,500, and I can't do that with a forklift or a VNA, we're usually going to a few of our partners and having them custom build a format. And that's one of the unique things we offer, is we can actually get you a custom built AMR. It's all the same guts and electronics that they're selling on their normal models. But for instance, one of the companies we work with moves 30,000 pound rolls of toilet paper. And they built an AMR to do that, and we sell that. And because they can do that roll of toilet paper, they can make form factors of any size I want. Does that answer the range, or was that a good example?
I think it answers the range and gives both Vlad and I so many things to think about. So
was the toilet paper one a little bit of a crappy answer?
No, I think it makes sense. It's I mean, I've seen paper mills, so I can imagine that big of a role. But
Vlad, my man, it was a joke. It was, yeah. I think Dave and I both think that it's funnier. You guys will have to comment below if you think it was as funny as Dave and I, as Dave and I did. But Vlad, I have my train of thought is completely gone. Where are you at? What questions do we have for Dave?
I want to get back to like the AI and ML. I think we've touched on that a little bit right before the break, I guess, or the ad read. So you've mentioned that you're working with a couple of groups, one of which was MechMind. So I'm curious,
yes.
like what does that actually do? How does that simplify the programming process? As let's say, I know that it's like Corel for, let's call it like Fanuc. You can do it in like C# for a number of brands as well. Like what's the new way of programming?
So MechMind's a 3D scanning software that. Think if we're bin picking. In the past, you had to train the camera your part, give it 3, 4, 5 examples of each part you want it to pick. MechMind's to the point where it'll take a picture of the debris field of parts, and you can just go on your screen, and one of the demos we do is picking candy bars. We can say that's a Hershey's, that's a Twix, that's Almond Joy. And we can do that right on our computer screen, and then tell the robot to go pick the Almond Joy. Now, in typical bin picking, it's going to go down and pick. MechMind actually looks at the orientation of that candy bar sitting in the bin and goes in at the angle to pick it at an optimal angle. So it's pre-programming that path to pick up parts. Wonderful tool. It's out of China. Price point blows you away. If you're an integrator, this is something you have to add. If you're a distributor, why you're not carrying this is crazy. I do have a few military customers I can't use it in as a result, but a lot of my business is industrial. And this is a $18,000 version of what other people are selling for 65 grand. So cost savings of a half to 2/3 of what comparable products out there, less time to set up, literally out of the box, it works. The other one that we debuted last week that actually will program the path of the robot is a company called Augmentus, Augmentus. And Augmentus can use everything from a 3D laser locator scanner to 2D cameras creating a 3D image. And they're less expensive version. You take your iPad, you scan your part, you shade in with a stylus where you want the weld, where you want the paint, where you want it ground, where you want it sanded, anything path planning. And within about 4 minutes, it generates the robot code. So for instance, we demoed a motorcycle can to polish. If a robot programmer sat down, it would be a couple days to program that path, get the right force feedback, all that. This is generating all that in 4 minutes. So from days to minutes in programming, and you're not really programming, you're just running an iPad.
But so if I understood it correctly, you scan, so you create a 3D model of the part, or you can maybe import in something from AutoCAD, and then you can apply
Don't
the
need
path.
AutoCAD. And what we showed last week was actually a LMI Go-Cater 3D scanner. So basically, if you put your part in the table, the cell, if you will, it doesn't have to be in a perfect spot. You just bolt it down. The robot comes in, scans it, shows you a 3D rendering almost immediately. You then, like on the polishing app, you just shade in where the can is, and then it'll generate the code. You can go and tweak that code. Maybe you want it to dwell in that corner or on that angle a little less or a little bit more. Maybe you want a double weld versus a single weld. You can tweak those. So about 4 minutes to generate the code. Our programmers will spend another 10, 15 minutes maybe just playing with parameters. They run a simulation on it real quick. They hit go and it runs. So no robot code. And that is a game changer for our customers. This Augmentus is huge for path planning. MechMind we really like for pick and place. And again, they don't both do the same things. What we're kind of seeing in AI and robotics is there's a breakthrough here, and over here. It's not all encompassing. It's more specific problems are being solved through this machine vision, which I'm going to make my robot guys upset and call it basic AI. They just hate the term that I use AI. And again, I looked at it and I go, you know what? I was doing this for the military, providing mathematicians to do this kind of stuff on jets for the last 20 years. And they didn't call it machine vision. They called it AI. So I'll have that argument with anybody, but very advanced 3D machine vision type tools hitting the market. Yeah. What's cool about us is we tend to see these about 6 to 12 months before the market sees it. I have a guy named Blake Krieger. He's great at going out to these companies on LinkedIn and saying, hey, did you think of this? How are you going to handle that? What are you going to do here? So when they release their product, they fly to Minnesota and come to this tiny lab in Savage, Minnesota, and show Blake that they did a good job. As a result, we help them enter into the U.S. market, and we advocate for them as a result.
Good. That's how you should be driving some of the features ultimately, because you see it firsthand. And I'm assuming their strength is more in developing these tools and software versus, going and installing maybe the machinery. So I think that's a really good feedback loop. I'll say, yes. So I've not, worked on many like sanding applications, but it looks like they do some palletizing and depalletizing as well. So I'll have to read up on
MechMind is wonderful for palletizing, depalletizing. If you're familiar with Mugen, that's another product we sell. By the way, Mugen just is wow. If you haven't checked out Mugen, definitely check them out. What we like about MechMind is it's a lot more affordable and easier for other people to integrate on existing systems. So, again, there's different tools, again, palletizing, depalletizing to what we do for a lot of companies is we take it off a pallet and we put it into a Gaylord, or we're pulling it out of a Gaylord, which is just a big box, and putting it onto a pallet. And MechMinds allows us to kind of do those types of tasks very affordably.
Interesting. Let me ask kind of a follow-up, because you gave us a whole bunch of different interesting groups who are doing kind of very particular things, and I think that is how we see lots of these starting out. You having that extra 6 to 12 months of purview, do you imagine that we're going to continue to see numbers of groups pop up who are very good at very particular verticals, and we're going to go see adoption in those verticals? Or do you think that someone is going to come and condense them under one banner, and then there's one group who is very good at a bunch of these verticals?
I think there'll be a slight amount of consolidation in some tasks, but quite honestly, these different tools work really good in specific environments. And I think the environment is going to continue to drive what tools we'll use. And I don't know that an all-in-one would ever make sense in that regard. Okay. Again, I think you'll see some slight consolidation and it'll get better. But really what you're going to probably find out if you were to peel it back is they just took two systems, combined it into one at that point. That's what I see happening in the future. I see an Augmentus, incorporating a MechMind camera, using that pick and place to do assembly tasks better. And if they don't, we will be putting both of them on a system to do just that.
Okay.
Sounds like a private equity play, but...
Well, and there's a lot of IP that could be developed as to how this stuff gets used and how the systems go. And quite honestly, when you talk about private equity, they're funding groups like Augmentus, MechMind, Mugen, because they are developing intellectual property that can be sold and resold and licensed. The other thing too is, just to bring back to robots as a service, as we're layering some of these software, some of them are software as a service. And that's what I think will drive robots as a service on the ARM side, is if I got a $6,000 license here and a $1,000 license here and a $1,200 license there, that's where that robot as a service might become a better value, because I'd be building in those licensing agreements into your hourly rate. I think the third-party layering of these softwares, and particularly ones that do have a SaaS component, will force the robots as a service to just be a better value as we move forward. If that makes sense.
On my side, I think that makes sense, and I like it. I would actually like to go back to a slightly different point that you made, Dave. You had talked about coming and being like Kenmore, being like Sears and Roebuck. Of you guys have a bunch of different robots that are very good at different payload levels, that are very good as different things. So Infinity Robotics as a whole, and I don't know this question, are you guys mostly driven by applications and you guys go deliver the solutions? Do you do a lot of distribution and sales of other robots? What is the business model that you guys have gotten to be to this point? Or maybe where are you going?
And probably where we're going is the point. We've been what's called a boutique distributor in the past, as new products like when soft robotics hit the market, we were one of the first to pick them up, and we were a distributor in the area. So we've been what we call a boutique distributor, distributing just a couple specific parts. I don't want to carry a catalog of 500. I want like 4 or 5 things we carry. Things like MechMind, Augmentus, Pure Robotics, a couple others. I could see 4 or 5 things that we become a distributor on over this next year, partially because we have a lot of expertise and we're able to get them in front of customers, particularly other integrators. So we're used to having other integrators come into our lab and show customers some of our gear and then sell it to their customer. So we're conducive to that. And then we're probably this time next year going to start developing our own in-house AMR. And we're going to incorporate a lot of these vision tools into those types of products. So a little bit of a hybrid distributor, but really what I like is taking stuff, grouping it together and putting it into a product in a bundle. So I've got a good opening price for that customer, a good ROI, get them started down that road of automation. It's why we sell Flexiv. It's why we sell Universal Robotics. They're great entry-level type components that have a lot of flexibility, and then help them move into that industrial arm, which is going to be a little bit cheaper and run a lot longer in that heavier duty cycle as we identify it. So my employees like custom. They just like super hard, impossible problems, and that's all they want to solve. So I see kind of a split between the business, maybe a trifold, small focused distributor on some specific technologies that we think needs help getting into the market better. Productizing things like Kawasaki and UR and Flexive with these MechMind and Augmentus tools that we see coming into the market. And then our bread and butter and what my guys, the reason they work here is they get to see really wicked, super hard custom systems. And they just like to have headaches every day. I don't get it, but hey, that's what they have fun with. And as a result, we're able to walk in, and a lot of integrators are kind of dropping a cell in and solving a problem. With my team, we're able to look upstream and downstream, what's happening and how is this going to look in 2 years, and hopefully help that customer plan better for what that, we as we call it, the automation journey. Nobody just starts out plopping a robot down and says, we're done. It's okay. We solved that. How do we figure out the rest? So a lot of times when we're walking into customers, it's, hey guys, that's a science experiment. Just run away, forget about that. Keep hiring people there. Here's an off-the-shelf thing that can solve your problem. Here's something that isn't a science experiment, but it's going to need a lot of custom engineering to do it right. We want to be in that custom engineering, do it right, to that productized product, helping them, and then just letting them know, hey, I think, and because of what we're seeing in the pipeline, we think in 14 months we can come back and solve this science experiment for you. I don't want anybody paying me to work on a 14-month science experiment I can't solve.
I understand that. Vlad, as the engineer of this group, is about to get very upset at that previous comment. Vlad?
Well, no, I think that makes perfect sense. You don't want to be redeploying, as an engineer at least, obviously as someone in business, you want to be redeploying the same palletizing cell because it's, easy to replicate. But as an engineer, once you've deployed, 3, 5 of them, you're kind of like, hey, like let's look at something more interesting. But I could see how there's, a bit of conflict there. For
Well,
sure.
let me be clear. It's the engineers who don't like the products. They like the custom stuff. They're happy to support our palletizing products and our assembly products, but they really like it. We just got off a call right before you that it's a very unique multi-robot welding system for the chassis of a unique vehicle.
That's the fun.
And that's the whole fun. Looking around the room and the excitement in their eyes of, well, we've never done that. How are we going to position that? I love seeing that in the guys, and I'm glad I get to keep bringing those opportunities to them.
As a follow-up, and I guess maybe the last topic we want to hit on the stream, cobots. So I think that we all see that there's a lot more UR robot arms like going out the door. Like, what are your thoughts, like in general, when it comes to cobots? Do you see customers buying more of them? Do you see them utilize them in a way that makes sense? Like, what are your thoughts around cobots?
Well, so we carry, everything from FANUC, Flexive, and UR. I have to be honest, the last few years, I thought most of the applications have been almost worthless, not quite utilized the right way. A lot of people putting a cobot in an industrial setting that the duty cycle. One of the reasons we work with UR now is the do-it-yourselfers have kind of done it with cobots. And we're now to that point where throw a third-party software, throw some vision, throw some fixturing, a more custom type gripper solution is what they need. And surprisingly, I'm seeing that market pick up a lot for cobots, whereas I was wondering a year or two ago if it wasn't dying. Since then, we've picked up UR. Great product. There's a lot of stuff that integrates it. So when we talk about products and a good price point for customers, we love them. We really like Flexive because it has the built-in force feedback. So instead of buying a $50,000 cobot or a $35,000 industrial arm, it's about a $50,000 cobot with the $30,000 force feedback. Each joint has force feedback. So think sanding, grinding, application of adhesives, things like that, where you want to know you got the right pressure. And as a result, Flexiv is actually an adaptive cobot. It'll actually adjust its path depending on the product moves to a certain point. So we've gone from cobots to wondering if that market was going to go to now we're seeing adaptive cobots enter the market. And I think that's solving more complex assembly problems as a result. If we want to snap like a electrical connector in, we get a force feedback symbol thing that tells us perfect insertion, or that didn't look right, put it in the reject pile and have somebody inspect that. So we're seeing more actual applications of that interaction with the human and assisting that human. We really like cobots for kitting. We like it for adhesive application. We have cobots now that'll free float like a caulk gun. So kind of like you remember the old springy things. The cobot will do that for you, which is great because you got 3 parts you got to apply that adhesive to. You train it on the first one, you hit go on the next 2, and you only had to train it the once. So we are seeing more use cases, and we're seeing more industrial uses of cobots as a result.
Yeah, I think it's really interesting. I feel that I've always discovered like a new brand in every conversation. How there's like very niche, I feel like applications not only of robotics but also like of cobots that solve again like very narrow or interesting problems. And I certainly think we're going to see more and more of them. And I think that the price point of that technology will hopefully kind of level out with the current robots. But it's very interesting. Like, and again, it's also not just on that side that the cost is reduced, but ultimately the safety required is less, right? Like you don't have to build like all the garden, you save space. So there's a lot of, I want to say,
Well,
like
let me
extrinsic.
stop you there. One misconception is that cobots are cheaper, and they are the most expensive way to go. I can put an industrial robot in for about 5% less than I can do a cobot application.
Do you think it will converge to that
It's
price
not a
point or no?
huge gap. It could, but so basically, if I'm buying a $50,000 cobot, a Kawasaki of similar payload and capability, way more capability, is going to be in that $32,000 to $36,000 range.
Okay.
Unfortunately, I'm putting $10,000 worth of safety cage or scanners on that. So, I'm in that mid to low, low to mid 40s as a result. But, that's a huge misconception people have is the cobot's going to be a cheaper way to go. They also think that the cobot doesn't need a cage. As soon as I put a sharp object, a knife, a chainsaw, blowtorch, that cobot really should be in a cage or behind some sort of guarding. So a little bit of misconception, I think, in the market for what that cobot could do. But when we're talking the typical pick and place or assembly process working next to a human, hands down, cobot's the way to go. Does that help a little bit, Vlad?
Yeah, absolutely. I guess like it's I had the same train of thought. Like, but again, I think my opinion is that the prices will at some point like level out or converge a bit. Or the cobots are going to become cheaper, but who knows? It's
I think the only way that's going to happen is we're seeing some really good brands coming out of China that are pushing some pressure on the European cobots we're seeing. Even the ones we're buying out of China are still more expensive, just as expensive as the European ones. A couple American versions being made that look like are decent quality. I think they've got a chance. We'll see how that looks over the next year or so. I don't know, based on talking to the cobot companies, that they have any desire to ever lower their price. They seem to have them niche. They seem to be selling them. And there just doesn't seem to be a lot of pressure over the last 4 years that I've seen to, I don't want to say even lower the price, but maybe just be a little more competitive. So I think that's going to be a slog, and we'll see how that goes over the next couple of years. And the other thing, like we tell customers, there is a, for that $10,000 or $15,000 savings, you think ease of use, serviceability of the European models are awesome. Everything integrates with the UR. It's a great robot to go with. The small premium you're paying is well worth the ease of use. And hate to say it, because I said it earlier, they are a lot more redeployable than most other robots out there. You're going to be able to find those human uses. That doesn't change much. Where I say robots aren't really redeployable, sometimes when we get into massive industrial systems, that 2,000 kilogram robot is not going to be a good welding robot for you. It's not going to be a palletizer.
Mhm.
That 13 kilogram industrial robot that's welding for you is probably never going to be a great palletizer. And you have to be careful because depending on the brand, you have to turn on certain features to do certain things. And if you want to be cost effective, you better do that when you order it new. We had a robot that we had to turn on a couple features that weren't when it was bought. The robot, after being used for 5-6 years, was probably worth $8,000. We paid $16,000 to turn on 3 switches. And it was a timing thing for a trade show. It just, there was, the 10 grand didn't matter. The 15 grand didn't matter. They had to have it in their booth.
Yep.
But that's why I caution people, don't buy that robots are totally redeployable. They can be in certain situations. When we do talk about robots as a service, and that needs to be a redeployable robot, it means we're taking that palletizing cell, pulling it out of your company and putting that palletizer in somewhere else. We're taking that specific welding cell and plopping it down into a new company. We're not necessarily redeploying how the cell is used. So probably an important determination to make as we confuse the snot out of our listeners here.
No, I think that's a good point to make. And every time I think about redeployability, I think it's where if we're going and redeploying it, we're redeploying it in virtually the same application. To your point, Dave, a welding robot is a welding robot. If we take it out of one company, like even if we were to go buy a scrap welding robot from someone, basically one of the very few things it'll ever be able to do after refurbishment is weld, right? That is what it was designed for. That is what it is good at. Similar to any 2,000 kg robot, similar to any palletizer, it's probably going to live in a palletizer. It's probably going to live in a palletizer that has a lower duty cycle than what it did for the first X number of years of its life. But redeployability is, we're never going to be able to take one robot and turn it into every other type of robot. If we could do that, now that would be a business model. Dave, I want to go transition. I'm going to go ask you one of my most favorite questions that I get to ask all of our guests. I would like you to predict the future of robotics, and I feel like we have talked about so many topics. I'm going to leave it very open and get and hear what your thoughts are. And for our listeners at home, Dave just ran off of the camera.
I don't want to alarm you, but I think what we're seeing overseas right now, this is probably the future in some regards. I hope we're not alive when we have to face it. I think the future of robotics truly is changing the way we live on and off this planet. And that's, if you walk in our front door, you're going to see on the wall, change the way we live on and off this planet. At Infinity Robotics, we strongly believe that we're in the next century heading to 60 billion people on this planet. And we think through automation and robotics, we can provide meaningful, useful lives. We can feed those people, and people can exist on this planet in a wonderful, meaningful way. I think one of the things we're going to see, the biggest thing in robotics, is I am trying to get designated to Minnesota the world's largest spaceport to launch mining robots to the moon, Mars, and asteroid belt. And by bringing back resources from our solar system, we're going to be able to take some of the burden off our planet, reduce some of our pollution, and again, support really an unlimited amount of people on this planet. And everything we do every day is to improve the lives of the humans who are in those factories and the people who would buy those products from that factory. So I do think the future is in agriculture, automating how we do agriculture. I think we're going to see some massive breakthroughs in AIs. Almost every company I'm working with is building bipedal robots, so humanoids. I think that humanoid factor is going to be wonderful because I think our exoskeletons are going to get better for disabled people to give them a more meaningful life and more interaction within our society. I see a lot of positives. I don't see a lot of negatives. We always worry about the Terminator aspect. I do think we should stop sending children to killing fields and slaughtering them over a piece of land. I think the robot should just handle that. I don't want to see it go there yet because having been a weapons manufacturer, you deal with that merchant of death kind of thing on your soul. Am I protecting people? Am I hurting people? But I really think the future is, going to be in our homes. helping the elderly to be more independent, longer in their lives. But overall, I think robotics and automation is going to have the biggest impact on humanity. I often am dealing with customers that are not looking for ROI. They are done hurting their people. And that couple $100,000 is not going to keep them from buying an automation system to stop hurting their people. And those are the customers we love to work with. They're improving their employees' lives, and they're having a huge impact on those families and how those families are going to progress for the next couple generations. I think there's a bright future in it. I'm more terrified of AI in IT than I am in robots. Trust me, we're doing some super cool stuff, but they're not going to be very self-aware anytime soon. Even if we're making the humanoid, I think they're going to be under very constrained. Our computers aren't doubling and tripling like they were, and we do not have the computing power to become, the Terminator type thing. So that's kind of my take on the future. Is I think companies, Dave, guys like you, Vlad, us, people are listening to us. We're going to be applying this to help people live better lives, more meaningful, not wear their bodies out, and actually enjoy their retirement when they get there.
If I can make a comment, Dave, before I let you ask the next question, one thing that was on my mind for quite a bit of time was there was an article, I think it was now probably 5 years, that was released by a fairly large media company where some robot killed someone and it was AI taking over, right? The title, obviously they make it very sensationalist, and some tire robot killed someone, but ultimately I think the people in the field understand what the limitations are. But what worries me is that it's kind of one bad actor could set the tone that this needs to be banned in a way, which I think is a very interesting dilemma, right? Because I think if we allow someone to half bake an AI robotic solution, and whatever happens that doesn't turn out good for the public could ultimately stifle the innovation that happens in our space. And I think there's going to be interesting political debates on that side in the years to come.
I think there's a lot of misinformation out there about that. I can tell you the robot AI probably didn't really kill somebody. It was probably more of a human in the loop, or
of course,
ignoring something
yes,
obvious. I do think you're going to see AI on the battlefield that will be making those decisions. And to be really clear, we deployed those systems about 20 years ago. They aren't happening. They have happened. Mm-hmm. We're using a ton of AI on the battlefield to help commanders make better decisions, to help reduce civilian casualties in a conflict. And that's what kind of drove me to going to robots. Was I knew we were doing this for aircraft and different weapons systems. Why not do this for factory helpers? And real quick shout out to Matt Adams. Yes, RoboDK is a great tool for that. Ready Robotics is great for redeployment. I do think cobots are fairly redeployable. I think the misconception is industrial robots are not as redeployable as people would like to think.
Absolutely. No, I think that was great. I love the generally positive outlook, at least the middle part of that prediction of the future. And thank you for going to answer Matt's question. I was, in fact, going to go bring that up because I thought it was interesting. And I feel like of all the robotics conversations we've had, the one major one we didn't touch on was simulation, but that's because there are always too many things to talk about and never enough time whenever Dave and I get on a call. But no, thank you so much for that. Next question, Dave, I'd like to ask for folks looking to get into robotics, generally kind of like early career, maybe looking to get into robotics for the first time as early career, or mid-career looking to transition into robotics from maybe more of a controls background. What sort of career advice would you give for them?
So as a 20-year headhunter for engineers, we were 4-year degree snobs. I love to see the electrical engineering with a mechanical aptitude, or a mechanical engineering with an electrical aptitude. If you can do the math and sweat out 4 years of school, go get your 4-year degree. I don't care what anybody says. It is well worth it in mechatronics. However, if you want to go get your 2-year degree, we are paying people a fortune 3-4 years out of school. So 2-year degrees in mechatronics, whether it's controls, robot programming, that overall automation background is a great thing. What I do stress to the 2-year and 4-year people is actually do something while you're at school. If you show up on my doorstep as a new grad, you have really not a lot of skills. You got some basics. but I want to know what special projects you did. What do you work on cars at home? Did you rewire your mom's stereo? I mean, we want to see that technical aptitude being applied, and those are the people we hire out of school. But the 2-year any mechatronics degree is great. It doesn't matter really what your background is, because there's a spot in robots for you. I didn't know anything about robots. I was just unemployable and started a robot company. I have the gift of gab, and I can sell. Fortunately, I was smart enough to go to all my competitors and hire their top guy and make them a partner in my company. So I rely on their brain trust to make sure what I'm sharing with customers is accurate and deployable. But that 2-year training, there's marketing people we need. There's sales people. There's, back office. So look at your skills and see if you can't take a few classes to kind of get up on the vernacular and kind of understand what's happening in the market. And what I did is I went and worked for another robot company for a few months before they decided they didn't want a good sales guy. They wanted me out of there, and I was very happy to leave and go start my own. So go work for somebody, start at the bottom, work your way up a little bit, put a year or two into it, but get into automation, get into robotics. Most important thing, as I mentioned before, don't just learn how to program the robot. That's only a portion of the system. Understand PLC and controls. Probably half of our robotic systems all have to do with PLC and controls. You don't have to be that engineer who does it, but you better understand how to use it. And once it's deployed, how do you help maintain and program those systems to stay up with changes at the company? So when I have a robot programmer who can also pull up the PLC and tweak code, those are the golden. And most of our high-end, super brilliant robot programmers are going back and learning PLCs. There's companies out there that can help you achieve this. Soulless PLC is probably the best one I can think of off the bat because it's in front of me right now. And yes, I am.
Thank you, Dave. Appreciate it.
But
the plug. I appreciate the plug, Dave. I think that is great. I want to transition this kind of maybe back to some of the other conversations. I want to know what you're reading, what you're thinking about. I know you've talked a bunch about AI, but what are you reading and thinking about today?
So I don't have I typically don't read books. I read a lot of trade manuals and a lot of stuff online. I've been thinking about AI for 40 years. Since I was a teenager, I've been doing experiments to figure out how we get to certain decisions. And as a result, I'm looking at quantum computing, which I think is not sure it's ever going to happen. But what the funny thing is when you read about these quantum computers, it comes down to probably the secret to AI. And it isn't going to be a quantum computer. A quantum computer is basically an analog computer. And I think an analog computer is how we should be running AI in the future. Our inputs are analog, our outputs are often analog. We may have a D to A converter, A to D converter in between doing some tasks, don't get me wrong. But what if we were taking actual touch and taking that feedback into an analog sine wave to know how much pressure we've applied now? And now with that touch, we could start making basic decisions. Having worked with people with handicaps and stuff, training them in industrial settings, we are probably way overthinking what AI should be doing. And I kind of wonder if a simple analog computer wouldn't be the first step to figure out, and all decisions come down to 3 choices. 1 set of 3 choices, 2 sets of 3 choices, 3 sets of 3 choices. We're usually at a destination. Analog might do that better because we could use that force feedback, that sense of touch that robots are starting to employ. And when we're going back to welding or material handling, we're going back to an analog signal. Now, I'm not saying we don't have a DDA converter that tells that robot joint how to move, but specifically, how do we make decisions? And one of the best analogs I found right now that we're probably at an AI is we are probably at slime mold. People don't realize how smart slime mold is. It's a path planning organism. We're somewhere just above what I think slime mold is. And my hope is to see over the next 4 to 5 years, we're getting closer to what a gnat can do, or maybe an ant. Again, we're really overthinking what AI is going to be. And I think till we break it down to its basics, like we're seeing with some of the products hitting, and again, it's probably going to come down to layering 2 to 4 of those products into some sort of processor that then identifies path and procedure for the robot to follow. And we've actually are talking to a major car company next year about starting that type of, how do we get that, I don't want to say cloud or server, whatever term you want to use, making some of the decisions and hard thinking for that robot. Now, if I could just get the inputs and outputs into what they really are, which I think is going to be an analog driver. And of course, most of my friends at Micron and IBM do think I'm insane. Yet they still keep talking to me. So, I think they see there's something to it. I don't know what it is yet, but I have been driving for 40 years to figure out how we build a simple AI system. And I've come to the conclusion, I wonder if we're missing the boat on using analog versus trying to go to quantum computing, where while I've designed a couple quantum gates, I don't think any of it's going to work as a computer as a whole, at least not probably in our lifetime. Maybe 50 years from now. But I think quantum.
Interesting. I think all of these last answers have given us so much to think about, Dave. I think that's great. I guess I want to ask you the last question that we ask all of our guests is how can our listeners help you? Are you guys looking to hire? Are you looking for new clients? You looking to have interesting conversations? How can our listeners help you guys at Infinity Robotics?
So as a sales guy, I'm always looking for interesting projects to take on and support. So if you have questions, call. We'd love the client side. We are growing, and keep an eye on us on LinkedIn. We usually announce it on LinkedIn as we are. I will probably start hiring again in January. I think we're okay for this year, and we're kind of swamped with some projects. But customers, we're always looking for good customers, and definitely, if you're looking to get into this field, I was a headhunter forever. Happy to tell you my own personal opinions. I'll look at your profile and I can tell you what I think your path might be in this field. I am a little blunt as a recruiter, former recruiter, so don't expect somebody to sugarcoat it for you, because let's be honest. I might
take you up on that.
Well, and please do. The key to it is you don't need it sugarcoated when you're trying to make a major life change. You need blunt, hard facts, and there are paths to get here. And I got to be honest, I've talked to a few people where, stick with what you're doing. I work with a lot of entrepreneurs or people who want to be an entrepreneur. And a lot of times my question is, okay, you want to mortgage your house, go into debt, make zero money, and you're willing to give up your $250,000 a year salary to do this. And they'll look at me and go, well, that isn't what I want to do. I go, if you're going to be an entrepreneur, that's your path. Guys, robots aren't as bloody. Most of our people who have 4-year degrees have gone back and gotten a 2-year mechatronics certificate as well. So going back, even if you think you're 4-year whatever, go get that mechatronics degree. What you learn at that trade school in 2 years will open your eyes to a whole new horizon.
Absolutely. I think that this has been amazing, Dave. Thank you so much for all of that. We will absolutely have to have you back on in the future. Everyone, thank you for hanging out with us. If you have made us this far and you're on LinkedIn, please be sure to follow Dave and Infinity Robotics, as well as Vlad and myself and Manufacturing Hub Network. Again, we want to thank Solus PLC and Vlad to just embarrass him one last time today for sponsoring this robotics theme. Go check out solusplc.com and the robotics courses they had. If you guys have made it this far in podcast form, please remember to go like and share and follow this and rate us 5 stars and all of those awesome things that you can do, which allows us and everyone else to continue to listen to more of these shows. And thank you so much, everyone. We will be back same time, same place next Wednesday at 4 o'clock to finish our robotics theme. But until then, we'll see everyone soon. Thank you. Bye-bye.
Thank you so much.
Thank you.